When dealing with current carrying conductors in the same conduit, understanding ampacity adjustment is crucial for electrical safety. The question often arises whether you need to adjust the size of these conductors, particularly when they are in a conduit longer than 24 inches and there are more than 3 conductors present. The key factor here is whether these conductors will be used simultaneously. If the conductors are never intended to carry current at the same time, the adjustment factors for multiple conductors in a raceway do not apply. Consider a scenario where you have conductors for heating and air conditioning in the same conduit. The heating system and air conditioning system will never operate simultaneously. The conductors for these systems do not require ampacity adjustment based on the number of conductors in the raceway. However, if the heating and air conditioning could potentially operate at the same time, the adjustment factors would need to be considered. The National Electrical Code, or NEC, provides specific guidelines for adjusting the ampacity of conductors based on the number of current-carrying conductors in a raceway or cable. These adjustments are necessary to prevent overheating and ensure the safety of the electrical system. To determine whether adjustment is needed, you must first identify all the current-carrying conductors in the conduit. A current-carrying conductor is defined as a conductor that carries current under normal operating conditions. Neutral conductors that only carry the unbalanced load from other conductors of the same circuit are not considered current-carrying conductors. Grounding conductors also do not count as current-carrying conductors. Next, count the total number of current-carrying conductors in the conduit. The NEC requires adjustment factors to be applied when there are more than 3 current-carrying conductors in a raceway or cable. The specific adjustment factors are outlined in NEC Table 310.15. The adjustment factors are applied to the ampacity of the conductors as determined by NEC tables such as 310.16, which provides ampacity ratings for various conductor sizes and insulation types based on temperature ratings. The allowable ampacity of a conductor must be reduced according to the adjustment factors. For example, if you have 4 to 6 current-carrying conductors in a conduit, the ampacity of each conductor must be reduced to 80% of its normal rating. For 7 to 9 conductors, the ampacity must be reduced to 70%, and so on. Let's consider an example. Suppose you have 6 current-carrying conductors in a conduit. Each conductor is rated for 30 amps at 75 degrees Celsius, as per NEC Table 310.16. However, because there are 6 conductors, you must apply an adjustment factor of 80%. This means the adjusted ampacity of each conductor is now 30 amps multiplied by 0.80, which equals 24 amps. The conductors must be suitable for the adjusted ampacity of 24 amps. If the load on each conductor exceeds 24 amps, the conductors will need to be upsized to handle the load safely. It is important to note that the adjustment factors only apply to the portion of the raceway where the conductors are bundled together for more than 24 inches. If the conductors are only bundled together for a short distance, the adjustment factors may not be required. In addition to the adjustment factors for the number of conductors, there are also adjustment factors for ambient temperature. If the ambient temperature around the conductors exceeds 30 degrees Celsius, the ampacity of the conductors must be further adjusted. The temperature correction factors are also provided in NEC Table 310.15. To apply the temperature correction factors, you must first determine the ambient temperature around the conductors. This can be done by measuring the temperature with a thermometer or by consulting local weather data. Once you know the ambient temperature, you can find the appropriate correction factor in NEC Table 310.15. The correction factor is then multiplied by the adjusted ampacity of the conductor to determine the final ampacity. For example, suppose you have 6 current-carrying conductors in a conduit, each rated for 30 amps at 75 degrees Celsius. The adjustment factor for 6 conductors is 80%, so the adjusted ampacity is 24 amps. Now, suppose the ambient temperature around the conduit is 40 degrees Celsius. According to NEC Table 310.15, the temperature correction factor for conductors rated at 75 degrees Celsius is 0.88. This means the final ampacity of each conductor is 24 amps multiplied by 0.88, which equals 21.12 amps. The conductors must be suitable for the final ampacity of 21.12 amps. There are some exceptions to the ampacity adjustment rules. For example, adjustment factors are not required for conductors in free air. Conductors in free air are able to dissipate heat more effectively than conductors in a raceway or cable. Therefore, they do not require ampacity adjustment. Another exception is for certain types of conductors that are specifically designed to operate at higher temperatures. These conductors may have higher ampacity ratings and may not require adjustment. Properly applying the ampacity adjustment rules is critical for ensuring the safety and reliability of electrical systems. Failure to properly adjust conductor ampacity can lead to overheating, insulation damage, and even electrical fires. Therefore, it is essential to consult the NEC and other relevant standards when designing and installing electrical systems. In summary, firstly, determine if the conductors will be used simultaneously. Secondly, if they will not be used simultaneously, ampacity adjustment due to the number of conductors in the conduit is not required. Thirdly, if simultaneous use is possible, count the current carrying conductors. Fourthly, apply the appropriate adjustment factors from NEC Table 310.15. Fifthly, consider temperature correction factors based on ambient temperature. And sixthly, ensure the conductors are suitable for the final adjusted ampacity. By following these steps, you can ensure that your electrical installations are safe and compliant with the NEC.